So, if the temperature of the first one is cut in half, this is cut in half, right? And the pressure is doubled, or halved. They said you could halve the second one. I don't know how you would write. There's lots of ways you could write that. What would that mean? Oh wait, maybe I could write it a little different. Well, what happens with that 2? Do you guys realize what happens with that 2? Let me write it a different way. The ideal gas law is, it's still the same thing, but it's done a little differently. So my final pressure, let me read this again. It says, if the pressure is doubled, so P2 is really 2 times P1, right? And T2, it says that the temperature is cut in half. So T2 is really the original temperature 1 cut in half. Okay? And then it wants to know what's the relationship of the volume when we compare the original volumes. So when you divide by a fraction, you really multiply. So I've got 2 P sub 1 V sub 2, right? You really multiply by the reciprocal of the fraction, right? When you divide by this fraction, you multiply by the reciprocal, which is 2 over T1, right? So then that becomes 4 P1 V2 all over T1. So now to find the relationship, they want to know how the volumes change. I'm going to start with P1 V1 over T1, and now it's equal to 4 P1 V2 over T1. Now the reason Mr. Adams set it up this way, and I do realize that my voice just cracked, I caught it, is that when I take this whole thing and multiply it by T sub 1, these T's cancel. And then when I divide everything by P sub 1, these P's cancel. So what I'm really left with is V sub 1 is equal to 4 times V sub 2. Okay? Now what I really would, now here's what I want to compare. It says, what is the ratio of the final volume to the initial volume? So I really want V2, V1. So what I'm going to do is I'm going to divide both sides by V1 because I want to compare V2 over V1. And I get 1 is equal to 4 times V2 over V1. Then divide both sides by 4 and I get 1/4 is equal to V2 over V1. Okay. Now what that's really saying is that if I double the pressure and cut the temperature in half, I will decrease the volume. If it's like a balloon or something like that, right? If the container can move, then the volume would change. And if I compare the volume of the final volume to the initial volume, it'll be 1/4 of what the original volume is by doubling the pressure and cutting the temperature in half. So if I took a balloon and I blew it up and it had exactly 1 cubic meter, right, in volume. That's a pretty big balloon. But if that's what it was, and I doubled the pressure, in other words, I increased the pressure of the room that the balloon was in, and then I cut the temperature exactly in half, the pressure would push it down. The temperature would cool the molecules in such a way that they won't move as much, and the volume would be exactly 1/4 of what it was originally. Does that make sense to you guys?